improvement of the of the internet. So if you've ever tested something that connects to the internet or is part of the internet, this will probably be interesting to you.
Or if you ever look at any of the like marketing materials where network vendor says our device does this many things per second.
Yeah. Are you guys, what open source tools are you guys using for these measurements, or are you using open source tools for these?
So I mean, this is mostly writing of the documents.
Sorry.
There are some of the tools which are open source stuff, and I think actually at the last meeting there was some discussion on a tool whose name I've completely forgotten, which was, hey, we implement RFC blah blah blah, and here's how. But I completely swapped the name out.
All right. Thank you.
No worries. Let me quickly go say hello to Bello.
I'm sorry, I knew you would hate this shirt. I'm worth for you.
Thank you. I don't know why they want to chat because every song sounds the same. Some of them like that.
I'm not going to fight you. You're allowed to have your opinion.
Even if they're wrong.
Sorry to you.
Trying to suck you into a fight, but you're just not taking it.
Okay. Well, I can tell you a bunch of different songs to try to change your mind.
Let's agree to disagree.
Well, I see some old friends out there now. I see Bill Fenner. Hi, Bill. And I see Caridi way in the back. Is that you, Caridi?
It is me.
Okay. Well.
She's already given me a ticket. Really? Yep.
So I mean, what actually happens? She's just like, hey, you need to be wearing a mic.
So I was at the reception, and everyone was holding something in their hand and eating and drinking. So I pulled on my mask. You're not wearing a mask. I'm going to set the COVID officer on you. So anyway, she comes by, and she says, I know you're holding a bottle, but it's not open. So please put your mask on. Yeah. I appreciate that. I didn't have a problem.
All right. It's actually 3 minutes after the hour. So I think we'll start slowly with the preliminaries here. Sarah, I haven't heard your voice yet. Are you able to activate your microphone? Not yet. All right. Well, we might as well get started, at least slowly here. So welcome, everybody. We've got, it looks like we've got about 15, 14, 13 people online, and 3 in the room, all of us who are sort of well known to each other. And thanks so much for joining us. So it's 0 dark 400 here in Chicago, and even worse on the West Coast. And in Seoul, it's not too bad. It's about dinner time. So we're glad to get things going here. I'm Al Morton, co-chairing with Sarah Banks. And if you'd like to join our mailing list, this is how you do it, right down here at the bottom. So getting into it, It's Wednesday. We have an extra line in our note well. We work as individuals and we try to be nice to each other. And that's always worked, except for 1 or 2 times I can remember. But in any case, we're a good crowd of people that, as testers and folks interested in testing and the results of testing, we usually get along pretty well. So here's the note well, and it's a reminder of IETF policies in place. There's a patent policy and definitions of contribution and participation. Please read it carefully. And of course, if you're aware of any IETF contribution that's covered by patents or patent applications owned by you or your sponsor, and you must disclose that fact or not participate, and so forth. You should have heard this 5 or 6 times by now. So let's assume that's as written. Okay, our agenda here today is to talk about status of the working group drafts and the working group status in general. So we've got a couple of working group drafts lined up for presentation and discussion. And then we'll look at the draft that we've been trying to get adopted into the working group. I think we're pretty close on that. There was another email yet on that again this morning. We've got a couple of proposals that have been around for a while, and we can talk about some more. And then some new proposals related to segment routing, MPLS and IPv6 flavors of SR. So that should be exciting. And that's the total agenda today. I think I've got slides for every one of these now, so that's a good thing too. Any bashes to the agenda? All right, hearing none, that's good. We did the IPR thing. It looks like we can fairly easily cover Jabber, I think. Warren, if you sort of keep an eye on that, that would be great. Warren is our AD advisor. He's sitting up front today as our BMWG delegate and BMWG chair for a day.
Ooh, I get to pretend that I'm useful. It's great. I have the power.
Well, I would take it a different way, Warren, that today you get to pretend, all the other times you're useful. So thanks for helping out there in the room. So this should be fun. Let me move on to the next thing here. Here's the working group status. The EVPN draft got a lot of comments and discusses in IESG review. The bottom line is the authors tried to get to a point where they were addressing the comments, but no new file was ever submitted, and they sort of claimed that they were looking for one author was looking for approval of the other, and then everyone disappeared. So we set deadlines. We asked that other people take up the work. Basically, no response. So this is officially status dead now, and sad to see that. A lot of work went into it, but that's the way it goes. Next generation firewall benchmarking. We're going to hear a lot more about that today. They're working hard to resolve the discussed ballots, and one of those is going to require a transport area review request again, and Tommy Pauly is going to be the target for that since he reviewed it the first time around. Multiple loss ratio search has had a large rewrite sort of in progress. We're still working on that Yang model and that resolving that objection. And as I said, proposals keep coming. No new RFCs this time. We got a nice stable charter, which is fantastic. And we've got a supplementary BMWG webpage that tells you how to join up. So glad to share that link with you all. Milestones. The one thing I'm really bad at as chair is keeping milestones up to date. So they're not. I think somebody usually takes an action item out of the meeting to propose new milestones. Oh, hey, Sarah, you got your audio going?
You noticed, yeah, and I'll take the action actually to go through and update milestones with you afterwards, Al. Thank you. Good morning, all.
Good morning. Glad you got the audio going there.
Me too.
Fantastic.
It saves me some hair. Thank you.
All right. All right. So I think, yeah, that's it. That's it for the chair slides. Any questions on the status of the working group? Cool. All right. Then I guess I stopped this, right? And then I started up again with a new deck of slides, and that's this one. And hopefully you guys can see the new deck for the multiple loss ratio search. And that means we're looking for Vratko to step up to the virtual microphone and give us a short presentation here. So please go ahead, Vratko.
Hi. So this is my presentation updated. It is like similar to the draft. It is in the middle of the rewrite, so there should be less details than previously, but maybe more things to discuss. So we will see how it goes.
Sounds good. I'm moving you on to slide 2.
Yeah. So the previous versions of the draft were trying to describe multiple goals and multiple ways to achieve those goals, and the text was too interconnected and hard to parse. So we are doing a rewrite, trying to explicitly state different goals and explicitly state different parts of the solution of what we are proposing, and discuss what is possible on the smaller areas before putting it all together. Also, we are trying to get rid of the terminology we were using in the previous versions, names like NDR and PDR, non-drop rate, and partial drop rate, which is not the official terminology. So where possible, we are trying to use terminology present in previous RFCs. And yeah, so we were starting this rewrite, but we realized that it is way more work than we allowed the time for us. So it is in the progress, but for anybody interested, I think it is worth a read. So next slide, please.
Okay.
This is just, you can see this is an old slide. I have only updated the links. Basically, this is describing an algorithm that we are already using for quite a few years, and we are doing small improvements to it. But yeah, basically this is like a code first approach, and maybe this is why the draft currently is more complicated than if it was like more theoretical work. Next slide, please. Okay, so this is like a very quick overviews, trying to highlight the main ideas. One important idea is to search not only for throughput, which is the load that achieves zero loss, but also various loads that achieve a specific ratio of loss. It is motivated by some DUT's behavior. Basically, when you are trying to search for this throughput, the results are not very consistent. Basically, it is possible to start two trial measurements at the same load, and one of them gets zero loss and the other one doesn't. So you want to formalize this So it is for some types of DOTs, it is also interesting to find for this load that achieves some non-zero ratio, because this result is more stable. And one of the main motivations for our approach is to save time while doing the search. So there are multiple, like I can call it, tricks that can be applied. All of them are related to the way the load for the next trial is selected. Also duration, because it is possible to use shorter durations. And yeah, one more thing. Maybe you can go to the next slide. I'm not sure where I put it. Okay, so it is not there. Never mind. I will go back to it. There are some requirements that are kind of implicitly present already in RFC 2544, but they are not stated as explicitly as needed. This is mostly related to the discussion we had on the mailing list and also on these meetings. One big requirement is that the how is it called, test equipment has to be reliable. Basically, if you want to start a trial with some load, the test equipment should be able to really put as many frames in the allotted time as is required, because we know that for some setups the test equipment can struggle to achieve high enough load, and this is not addressed in RFC 2544, but of course it is very important. And there are other RFCs that are already describing basically difference between intended load and offered load, and we want to make the language of our draft to use those terms and make it clear that test equipment has to be reliable, and if it is known that it is only reliable up to some load, it is for the testing group or the person realizing those tests to ensure that the test equipment never attempts to send more load than it is able to do. And there is like a side question of how do you know how much your test equipment is able to do, which is another kind of worms. Our draft is not planning to offer a solution for those kind of questions. We just want to make it explicit that this is required and leave it to the people how do they achieve that. Also, another thing that was not present in RFC 2544 is any search stop criteria. Basically, it only says you either increase or decrease the load for the next trial, but it doesn't tell you when you can stop. So in our MLR search, we are also proposing some search stop criteria. Next slide, please.
Okay.
Okay, this is the real example. Basically, some of you have already seen similar presentations, so this is not news to you. This is here just for people that are maybe new, so they can see how does it work in the real life. And I will, if there are questions, I can go back here and describe what is going on. But just looking at the bold numbers, you can see that there are more trials aimed to examine the NDR, so zero loss ratio, and less trials aim to search for PDR. Next slide, please.
And that PDR is the partial drop ratio, right?
Yes. And as usually it is more stable, there are less surprises during the search. When in the NDR lower column, when you see N/A, that means that we have increased the duration, repeated the measurement with the same load that worked before, but now it didn't work. Basically, the same load, increased duration. Now we have non-zero number of loss, and we have to start doing the external search to find low enough load that achieves zero loss, and then continue bisecting to get to the required precision.
And you've got 4 phases here, this initialization, int1, int2, and final. And of course your final results come out in that final phase. And these are sort of your precision on the NDR offered load here at the bottom.
Yeah, basically, so you can see, for example, that the final trial duration is 30 seconds, not 60 as required, but by RFC 2544. This is our team deciding saving more time is more important than be fully compliant. But yeah, basically we have our precision goal. I think it is 0.5%. Okay, this is rounded values, so you cannot verify it, but basically that is it. And so for these values, it is basically 0.01 mega packets per second, I believe that is. And you can see that for the iteration 2, it is higher, and iteration 1, it is even higher. So there are some clever tricks to really try to do as few, to spend as few seconds as possible for the search. In this particular situation, the DUT was not very stable. You can see that for 1 second trials, 5.78 was enough, but for 5 seconds, we needed to lower to 5.6, and for 30 seconds, 5.26. So there is something going on the DUT that is causing occasional drops, and if you have longer duration, it is more probable for the drops to happen, even if the load is otherwise quite small.
Right. So those are the interrupts we're dealing with that we can't get rid of in the virtualized environment. They're happening for system functions that are necessary for health. So we got to work around that.
Well, work around. This is benchmarking, so we have to accept whatever behavior is. And
absolutely,
yeah,
absolutely.
But this is like one of the examples why we are choosing some values that are maybe not obvious, because this is an example of the search that takes longer than usual. In ideal case, you need only 4 measurements at 30 seconds, and now you can see there are way more than 4 measurements. So this is spending some time. So we were like trying to find good values that are resulting in fast search time, even if the DUT behavior is not as nice.
Right. Okay.
Okay, so we can go to the next slide. Yeah, this is basically me inventing numbers just to get to a scenario that is interesting. So if you can find it, there are, well, one cell with 2 red numbers and the other cell with 1 red number. Basically, the situation with the 2 red numbers is similar than before. And now for PDR lower bound, we have repeated the measurement, and instead of NA, I have written the NDR upper bound. And basically, one of the one of the questions with no obvious answer is what should be the offered load there. In this particular example, I have chosen the 20 to be the next offered load, which, well, let me talk about it one more time. So the third line from the bottom, we have measurement at 17 and measurement at 22. One of them is valid PDR lower bound, the other one is a valid PDR upper bound, but this lower bound is not coming logically from the previous search around PDR. It is just that NDR upper bound acts as a PDR lower bound, and we have nothing better. What we had better was invalidated. So the question is, what should we choose as the next load to get to the PDR? One possibility is just, okay, you have lower bound, you have upper bound, even if they are far apart, you can do the bisection. Another reasoning is that you have new PDR upper bound and you have old PDR upper bound, like a second tightest at a 64-second measurement, and you can do external search from there. And well, maybe even another approach is that if on this remeasurement the 22 value has failed, maybe it is a signal that the PDR will be closer to the NDR. So maybe we can continue external search from the NDR values, like 16, 17. Okay, so let's try 19. So there are multiple choices, and it is not obvious what is the best approach. In practice, it may depend on your experience, like what do you expect of your DUT? What do you imagine that the PDR lower bound will be at 64 seconds? But of course, if you want to specify the algorithm, it has to be deterministic. Well,
Right.
maybe now I can talk about it. One of the goals of the MLR search is to make this load selection deterministic. Because if you do not have deterministic load selection, you do not have as high repeatability of the result. Basically, if you run the search once, if you run the search second time, of course, you can get a different result just because the DUT behaves differently, but sometimes you can get different results if you use similar but not exactly the same algorithms. Basically, in this case, whether the next load is 20 or 19, maybe if you do simulations and repeat it many times, you can see that you get a different distribution of the results. Of course, this is only affecting devices that are not deterministic, but yeah, as we have seen, there are quite many devices that are not deterministic, and one of my goals is to have something that gives as small standard deviation when you run the same search on the same device multiple times as possible, while still having a small total duration.
So Reko, I think I'm struggling with two things here. First, and I'll take up the majority of this feedback to the list. The slides and what you're saying don't match, and they really need the color and context of what you're saying. If I were to look at these later on my own without the commentary or without looking at the video, I'm not sure these things hold. If I just look at the slide here, I don't exactly know what it's telling me without you explaining it. So thank you for explaining it. But I'll take some of this feedback to the list because I think it's just stuff that helps me make sense of the slides afterwards, and it's editorial. So I'll take that there. With the comment that you just made, I'm a little confused as to how this would, with just the comment that you made that, hey, even if the device under test is fed the same load, you're going to get different results every time. If the device is not deterministic, I'm not sure tailoring an algorithm to give you the smallest standard deviation makes, like, I'm not sure what the value is, because at that point, if the device is indeterministic, it is what it is. And I'm not sure why you would want to try to artificially reduce the standard the spread on the standard deviation there.
Well, yeah. So one thing is that this whole search takes time, and you want to run multiple tests, so you do not really have time to repeat the search. And sometimes you see from the results, like you change the duration, you get a different loss rate, loss ratio. Then that is a proof that the DOT is not deterministic. But sometimes you get compatible result in your one search, and you do not see that it was not guaranteed. So it is very hard to tell just from single search that DOT is deterministic. So you will get devices, and basically you do not know if it is deterministic or not. If it is deterministic, that it doesn't matter these details that I'm talking about. But if it is not deterministic, you are still facing the question: if different group measured the same device with the same test equipment and the same search algorithm, will they get the same or at least close result or not? And this is where I think it is good idea to design the search algorithm to at least increase the probability of the results being close together. I'm not sure how
And I know
important
this
it is.
it's taking up from Sarah's point, it's important to make the table sort of wide enough and the column headings useful enough to describe both of the numbers in each column, or just put a key to that someplace. And I would observe that if this was real data and you had 64-second duration trials, those would be really hard to make deterministic, sort of in the face of the transients that we're seeing in the virtualized networking world these days. So, but I think that's the same kind of thing that you encountered at 30 seconds and so forth. So, I encourage you to think about the transients and the steady state performance, which is what exists in between the transients, perhaps in different ways. I think you'll find that might help. It might help to add some determinism, and you may need to repeat trials too, the same sort of way that we did with the binary search with loss verification. I mean, that's been a valuable addition to a tried and true search algorithm, to repeat trials at a duration in between transients. Once we figured out what that typically is. So, as you're searching for quote determinism here and trying to make the algorithm deterministic, think along those lines too. I think that might help.
Yeah, well, basically, it's part of that reasoning went into our other draft, PLR search, that is aimed
Okay.
specifically for devices that can be indeterministic, but yeah, that is not even close to being finished. So we do not expect wide adoption there. But this is just making RFC 2544 and making throughput like more strict, the search algorithm more strict, so that the results are coming faster and, if possible, they are repeatable.
Right. So I guess the best thing to do is, as Sarah says, let's try to make the tables you're producing clear, and maybe let's look at some results together on the list and see what we can say about those.
Yeah, definitely. If you have specific questions, write to the list and I will reply. Basically, I was thinking about describing the current load selection, because basically showing the 6 values that are considered, like, the tightest lower bound, second tightest lower bound, tightest upper bound, second tightest upper bound, and tightest lower bound from previous duration and tightest upper bound from previous duration. Only those 6, at most 6 values are considered, and then there is some logic that computes something and decides what will be the next load. But I figured that first of all, it is likely to be changed for another draft version. There were review comments, I think mainly from Vladimir, that it may be more useful to finish searching from an NDR before starting a search for PDR. And yeah, currently I think that yes, in some cases it can save some time at the cost of me not being sure what the correct load selection rules will be. I expect they will be slightly more complicated. Yeah, basically I'm reading here. But and the other thing is that it will take, I believe, too much time for me to even go through that here while talking about. So what you see in these slides, yeah, it is like very condensed information. It doesn't make sense without my commentary, but I haven't found a good way to put all the required commentary on the slide.
Right.
When
Okay.
the logic
that
is
on the list, Frog. I didn't mean to disrupt your flow today. So I'll take those comments to the list, and thank you for considering them. I appreciate that.
yeah.
All right. So these are the next steps. I think we've got this now with some good examples. And is that pretty much it, Vreco?
Oh yes, I think that's next to the last slide. So that's all from me.
Okay. Thank you. All right. Incidentally, I've put our agenda into the hedgehog note taker thing, and we can just add some notes in there for our minutes as we go along. All right. So let's see what's next. Here we go. All right. I see Bala, and is Brian on too? Yeah. So
Yeah, I am.
very good. So whoever's going to present these, please go ahead. Thanks, guys, for putting the slides together.
Right. Next slide, Al.
Okay.
All right. So essentially, the draft is at the point where it's gone through the area director review, and we got a significant amount of feedback. So we have we received discuss submissions from 5 different participants, totaling an total number of eight submissions that we got to work through. We come to a resolution for 5 of them that are going to be proposed. We're looking at the remaining 3, and 2 submitters were Lars Eggert and Benjamin Kaduk. The submissions were interesting, and we believe that we have good solutions, but we are struggling a bit with how to respond to Lars and Benjamin, but we're working through that. I think Warren was had a question or comment.
Yeah. Go ahead, Warren.
Thank you. Yeah, just a quick note that it seems like you have everything under control. You know, it seems as though conversations are happening, and I've been staying out of it. But let me know if I should be doing more. But it looks like the conversations are happening, and you're all coming up with great answers. So,
yeah, it's the definitely is that, but saying it's under control, I think, is a bit generous. But thank you for that. So next slide, Al.
I'll just mention here that Ben Kadek is, I think he's stepping down from the IESG this time around and being replaced. So I think there's going to be a little bit of a changeover there as well.
So what happens in that case with his discuss points? Do they just go away?
No, I don't think so. I think what could happen is that Ben's replacement might pick up his discuss and then do his own review. But I think Warren's going to help me out with that. Go ahead, Warren.
Yeah, so the incoming AD takes over the outgoing one's points, but they may be less, not going to say invested in the document, but they may be easier.
They have a different opinion.
Yeah, thank you.
And I didn't even from what Ben said, I didn't think that his comments were, it was sort of like, I mostly have a question here, but I want to see it answered kind of thing. So
and it's just a matter of making sure that we give them an appropriate answer and understanding the interconnections resulting from the answer and how it could affect the rest of the document.
Good. Okay.
All right, next slide.
Yep.
So this is the lion's share of the issues. There's 69 comments. 66 we've come up with a path to address them. We do appreciate all the effort that has gone into the reviews. I definitely have. It's going to improve things significantly, I believe. There's 3 remaining comments that we need to come up with a solution on our side. I'm sure you can appreciate that 69 comments alone isn't a true representation of the impact, because when you make one change to the document, you have to sort of like trace it through the rest of the document and make sure that that there aren't any contradictions introduced and so on. And also we're doing our level best to ensure that that most of the changes we make are going to be editorial and won't impact in a significant manner the actual performance testing requirements. So
Good.
that's where we're working at. Next slide. So this is an area that we're really struggling with. So someone raised a comment about about the overabundant use of the word or the action should throughout the document, and I must agree that there was a significant number in there, and when I went through them with Bala, realized that a lot of the shoulds were us just trying to be polite, and sort of like, who are we to sort of dictate? There might be scenarios that we would consider a must under normal circumstances, but something could happen that would make it sort of, no, not really. And we thought, well, let's just make it a should, not really thinking about how this would play out within the IETF and how precise documents like this should be. So in the spirit of that, we went through it, and there clearly are a number of shoulds in there that will just change to musts. But where I'm having the biggest issue is the suggestion that if you're going to use a should, you need to explain why it has to be a should instead of a must. And I did some reviews of, and this was totally unscientific, but some reviews of other RFCs, and I don't really see any significant statements along those lines in other RFCs. Now, just because it's not anywhere else doesn't mean that it shouldn't be something that we do in this one. But I kind of have a hard time embracing that right now, simply because this has IETF-wide implications, and this is going to significantly impede the progress of the draft. So I'm concerned about that.
Yeah,
Brian,
I,
on one
I'm with
hand,
you on that, and I think that the real test of the process in my mind is where you believe you've been polite and you can't come easily to a reason why there's a legitimate sort of reason not to do the requirement, then it probably should have been a must or a shall anyway.
Yeah, I agree. I agree.
I'm kind of jumping the queue here. I heard Sarah and I know Warren's in the queue. Go ahead, Sarah.
Yeah, no, I agree with Al. Like, on one hand, Brian, I get that you probably don't want me on the ISG because I really agree with that comment, and I really agree with your observation that, yeah, it doesn't mean it's ubiquitously applied across all of the IETF, and some drafts or RFCs are better written than others. I totally agree with that. But I also agree with what Al's saying that, look, if you go through and you're eyeballing them and you can't really sort of identify, hey, why is this a should? Then I think Al's absolutely in the zip code of, well, maybe it shouldn't be a must, or maybe it should be a should, or you sort that out. The other thing, though, Brian, is it struck me as when you were walking through your talk track there. I'm not sure you have to literally account for every single should or must in the document, because to your point, some of these could be, look, under normal circumstances, a lot of these things would be musts and you would absolutely do them. But we put them as shoulds because we recognize that there could be situations in which you would want to totally change that. Anybody who's ever done testing understands and sometimes totally goes against what a draft says or an RFC says, because we have something in our environment that says, yeah, I get that that's probably normal for everybody else, but right now I have this new use case and it's changed. So the other thing is you could handle a bunch of your shoulds or your musts with that sort of broad brush to say, look, our guidance is in normal um, circumstances, here's how we see the world, but we accept that there are times where you might not be in that situation, and so it's okay to do this. And I'm wondering if that would alleviate the need to address specifically at least 110 shoulds in your draft.
Do you think, Sarah, that scenario that you just outlined, which makes sense, could easily be addressed with a short, paragraph on that topic at the top of the RFC?
Yeah, that's exactly what I would expect to see for sure.
Okay.
Go ahead, Warren. I think I used the power of the chair mic there to cut the line. Sorry about that.
Yeah, no worries. I mean, I'm just in the queue like anyone else. So yeah, I don't think that you really need to address, each and every one of the shoulds. I think it's worth going through and being like, yeah, this one seems reasonable, this one doesn't. I also don't know that you can entirely solve the concern by just saying, putting a disclaimer at the top being like, well, these shoulds are there in case you want to change your mind. What I think you can probably do is some of the uppercase shoulds maybe could be better done with lowercase shoulds. But also, if there are ones where it's easy to say when you can ignore the should, do that. But also, I think, have a chat with the AD and be like, we've done a bunch of them. I think it's relatively clear to whoever's doing this under what conditions they would ignore the should. So, are you okay with this? I don't know if that made any sense, if I just kind of like rambled for a while. But I mean, the easy ones.
I understand.
Okay.
I'm fluent in ramble.
Okay, great. Excellent. Like, I think that the comment was more like, hey, you should address these, not like you have to do each and every one exactly according to the following format. So yeah, we can chat with them.
And Rob, go ahead.
Yeah, I was just going to echo what Warren's saying, really. So I don't think that it's really fair for the ADs to go beyond what's in RFC 2119. So that doesn't say you have to have this extra explanation of when a should is not a must and things. I think it is sort of makes sense though in various places to do that. But completely to Warren's point, I think actually chatting with, is it Murray holding the discuss on this? I think if he's just asking in some places this is unclear, if you've looked through them and it looks like that's good and you go back to him, I would have thought that he's not going to be too strict on this. There is thought about trying to make this stricter in future, but I think that needs an update to RFC 2119. But that's just my opinion.
Yeah. I mean, looking at the comment, like rereading it, I think that some of it was more, many of these uppercase shoulds could equally easy have been lowercase shoulds. And maybe those ones, just replace the uppercase ones with lowercase ones and problem solved.
Yep.
Yeah.
Okay.
Yeah, that's an excellent point as well. Another option to deal with these. Very good. Okay. Was that it on the slides?
Yeah, that's
so.
it on the slide. So path forward then, given the feedback that we're getting, is that we'll do one update to the draft covering off everything. First order will be to get an email out to the various area directors for to address their discuss submissions and the comments, and then we'll deal with the shoulds, and then we'll do one update to the draft and submit it. And the main reason for that, of course, is just to move things forward, since we still have the RFC editor to deal with.
Right. And they, they'll help you with the consistency concerns that you had before as well.
Yeah, it's our first time doing this, and we were probably more sort of trying to lean towards being polite too much.
And one thing that Lars asked for was more transport area review, but since we've got one already, then Tommy's on the hook for that. And I think we can get him to look at this and respond.
Yeah, he seemed to be very interested in it.
Yeah. And basically Lars is still reviewing from the transport area point of view, even though he's supposed to be internet area now or general area as chair. So, you do what you do.
I think Warren raised his hand.
Yeah, go ahead, Warren.
Thank you. And yeah, waiting and submitting a new document with all of the changes is definitely an idea. Another thing you might want to consider is submitting a version, if you have one easy, that has addressed the initial set of discuss points, just because that way those ADs can clear them and you don't need to sort of wait around. If people have already agreed, yep, this will solve my problem, submitting a version with that, just those set of fixes in, will allow them to clear, and then it will get them out of their queue and they won't be sort of lurking at you. Whatever you like, it's just a tactic.
No, okay, yeah, that's definitely reasonable. What's the impact on the process then? Like if we do that, and then everyone is happy at that point, and then we make the changes with respect to the comments and the shoulds to the document. does that reset the clock as far as the area director review goes, or what happens?
I may have missed your question or misunderstood it, but I mean, at the moment, there are 4 people with discussers. If you submit a version which clears, for example, Eric's discussers and he's happy with them, he will then remove his discuss point, and he won't be able to come back later and reapply it or forget about it or something. I'm not sure if I answered your question.
Yeah.
Not.
It's sort of a one-time review thing, and as long as you don't have comment creep, which some of us have seen before, then but now all the comments are written and they're stored in the data tracker, and that's a lot harder to for anybody to get away with. So just consider updates of the draft that address specific comments or discuss blocking comments, and we'll knock them down as we can.
I mean, another advantage to that is, once you've addressed Lars's and the other one I can't remember who the other holdup was, we still need to actually get the people whose comments have been addressed and are happy to actually click the button saying clear. And, if they happen to be away on vacation that week or whatever, they might take some time. So.
Oh, yeah, I understand that.
Yeah. And it's just whatever you like.
Definitely.
It's really a tactic versus whatever.
Okay. Yeah, thanks for your suggestion, Warren. I appreciate it. I believe that's it now, Al.
Good. Great, thanks. All right. So next up, we've got I believe, a short talk with that we don't really need slides for, and that's going to be the working group adoption review on the Yang data model for network interconnect tester management. And I read out the whole title because the title is the crux of the objection. And I saw this morning that Vladimir has made a made a proposal of any titles. He's glad to accept any of about 4 or 5 titles that will work for him. And that's when I had to turn my email off to do this. So actually, the VPN more accurately. So Vlad has, and I see you're in the room. Feel free to turn your mic on there, remotely.
Hi.
Hi, good. Thanks for joining us. Have you seen any response to the your proposal from this morning?
Not yet, but I think the discussion is now focusing on pretty clear points, and I think that the argument that reusing network interconnect device as a term, although it appears a long sequence of nouns, it is still a noun that describes something that is known in the work group. So it should be considered as an option, even if Tom thinks it's long and complicates the sentence somehow. So I'm not sure the title should be changed, but I don't mind if it is changed. If it is made shorter, it kind of broadens the scope, which is not corresponding to what the actual contents of the draft is. Like if you say a network tester, then you include probably also the stateful protocols and other things that go outside of the scope of testing a network interconnect. Either it's a device or a more complex system, which is what the draft actually focuses on. So I think we can make the title shorter, but this will actually increase the scope to something that is not inside the contents of the draft. So it's up to the I guess the work group to agree on something.
Right, and also the I mean, you can aid the title by putting more scope in the abstract. At least it's fairly close by.
Yes, I agree. I mean, there are a lot of drafts that have title that implies a broader scope that the content of the draft actually has, and this has worked so far. So it's not a problem for me.
Great. So let's try to get some agreement on this fairly quickly, and then I think we've got potential adoption here. It's pretty unusual for us to get an objection about anything specific, and then the title ended up being the main sticking point here. So let's try to get past that in a good way and keep going. So thanks for your work on that, Vlad.
Okay, thank you.
All right, Rob, you're in the queue.
Yes, Rob Wilton Cisco. I was just going to make a quick comment. I didn't comment on the adoption poll, but actually I think this is a good piece of work. I think it's a good thing to be doing. I think that finding a sort of formal data model for programming these things will make it easier to write automated tests and then have those interoperate with different implementations. So I'm very supportive of this work. And
Thank you.
Hopefully the title shouldn't stop the adoption. That's obvious.
Right. I think we all agree on that. Okay. All right. So then now we're making good progress again. So up next we've got benchmarking methodology for stateful NAT XY gateways using RFC 4814 pseudo-random port numbers. That's a good long title too. But Keiichi, I think you're going to do the presentation today, right? I see you've got your mic turned on, Keiichi, but I can't hear you. Can anybody else hear Keiichi?
Nope.
But Keiichi, if you're on a Mac and you're really frustrated that your browser won't let your microphone work, I completely understand the struggle. Take your time.
Hello.
Yes, there you are.
Okay. So my headset didn't work correctly, so I'm now using my notebook microphone, so the sound might be a bit
It's fine.
not very good. But anyway.
No, it sounds good.
Okay. So hello. My name is Keiichi Shima from IIJ. And in this slot, I will talk about the latest updates of our draft, which title is this benchmarking methodology for states for NAT XY gateways using the pseudo-random port numbers. Okay, next slide, please.
Yeah, very good. And Keiichi, I'm going to give you like a 14-minute time clock here. The minute I figure out how to do that. Here we go. And just to try to divide the time among the drafts that we've got remaining. Okay.
Okay, I try. Okay, and this draft is a guideline to provide a reproducible and meaningful measurement procedure using existing benchmarking method for NAT XY gateways. Since these stateful boxes have to manage the connection tracking table entries, so we need some special cares. So this draft focuses on the three parts. The first one is a connection establishment performance measurement. The second one is a connection teardown performance measurement, which is new in this latest draft. And the third one is a kind of operation guideline when using pseudo-random port numbers when sending a measurement packets. So this is the 3 points of this draft. Okay, next please. Okay, this is the brief history of the draft. I think I don't need to explain this. So we have submitted the third draft this time, which include the connection teardown performance measurement part. And we have added some preliminary test results in the draft too. Okay, next slide, please. Okay. So this chart shows the overview of the test bed configuration. So I also don't think we need to explain in detail in this figure. But anyway, so there's a tester and a DUT, and the tester sends some measurement packets on one interface and receive the packet on the other interface. And when we do the bidirectional testing, we do the similar thing using the different interfaces. The point is that the DUT is a stateful box. So the DUT has to manage a connection tracking table in it. And we don't know, we don't have any control of the connection tracking table from the tester. But we have to synchronize. We have to have the same state table in the tester side because we need to do some kind of a testing using the opposite direction. So this is the point we want to discuss in this draft. Okay, next slide, please. And to achieve the reproducible measurement, we ensure these two things. So we split the test phase into two phases. The one is a preliminary test phase, which is focusing on the filling out the connection tracking table of the DUT and make a synchronized state table in the tester. And the second phase is the real test phase. This is almost the same as the other benchmarking method like RFC 2544. So the point is we have these two phases when we do the measurement for stateful NAT XY gateways. Okay, next please. Okay. This is page 6. Excuse me, can you go back to the previous slide? Okay, it's okay. So please move forward to the next slide. Okay, this slide explains the new items in this draft. In the stateful NAT XY gateway, it is important to measure the performance of the teardown operation of the connection tracking entries. To do that, we added a procedure to measure the performance in the latest draft. The basic idea is to delete the entire connection tracking table entries during the measurement process and measure the time spent for the deletion operation. Okay, next slide, please. Okay, this is what we have done in this draft. So we create a connection tracking tables in the preliminary phase, which is we create the number n of the connection tracking table entries in the DUT. And when we measure the connection teardown performance, we remove the entire connection tracking table by using some kind of out-of-band methodology like command line operation, remotely manage the command line operation on the DUT. So by measuring the time and the split, divide the total time to delete the entire connection tracking table. So we could get the ratio, the connection tracking table entry deletion rate by doing this procedure. Okay, next, please. And since this part is new in this draft, we probably have still some debatable points in this connection teardown measurement procedure. We want to continue the discussion in the BMWG list to enhance the quality of this draft. Just for your information, we have measured the teardown performance using Linux IP tables function and Joule NAT64 kernel modules using our technique. So we are going to show some results in the following slides. Please go to the next slide. Okay, this is some detailed configuration explanation of the IP tables experiments we have done. And the detailed result is also written in the draft. So if you want the more detailed information, probably you can check the draft contents. So in this case, we use IP tables functions, and we do the NAT44 address translation mechanism. And we have measured, especially for the connection teardown performance in this case, by changing several parameters of the NAT44 box. And the result is in the next slide. Can you move to the next slide?
Yep. Sorry for the delay. I was trying to grab a few notes there.
Okay. So this is a bit complicated table, but the actual values are is not very important. So the point is that each column is each different tests using the different parameters. The top row is the number of connections. The minimum one on the left side one is a 1.5 million connections. And in the largest case, in the right-hand side, we created 800 million connections on the NAT44 box using our testing procedure. And finally, in this case, we are focusing on the connection teardown performance measurement. So we remove the entire connection tracking table after we have created that much of the connection tracking entries. And the lowest row shows the rate of the connection tracking table deletion count per second. So in this case, we can see that almost 350 to 400 entries can be removed per second when we use IP tables of the other target DUT node. And again, so the actual value is not very important here. The important point is that we are providing some procedure to measure the connection teardown method for the DUT, and we could get this kind of a stable measurement result with our methodology. Okay, next slide, please.
Very good.
And this is another experiment, which is also written in the draft too, in detail. So in this case, we use the Joule, the kernel module, Linux kernel module, which is used as a NAT64 gateways. Next, please.
Okay.
And the same as the IP tables case, we have tested several different parameters. And the parameters are almost the same, but there is a little difference in the right-hand side. So this is because of some resource limitation of our test-bed environment. So we are sorry, it is not very consistent. But anyway, the actual absolute value is not very important. The important thing is we could provide some testing procedure for connection teardown performance measurement using this methodology. And just for your information, the connection teardown rate in Joule kernel module is much faster than the IP tables case. We didn't get into detail why this is much faster than IP tables, but the point is, again, the methodology provides some stateful and stable and reproducible procedure for the connection teardown methodology. Okay, and next, please. And okay, and this is the final slide of my presentation. And in this draft, we have added the connection teardown measurement method in the latest draft. So we have already provided connection establishment performance measurement methodology in the past draft. And we have also mentioned some kind of operation guideline when performing the packet forwarding benchmark testing for stateful gateways, stateful NAT gateways, when using with the pseudo-random port numbers. So this is a very important point because when we use pseudo-random port numbers when testing, the connection table tracking entries are getting larger and larger. So we have to manage to control the size of the connection tracking table entries. And at the same time, we have to provide some reproducible testing methodology for that type of stateful testing. So we have mentioned the 3 points as I have explained in the beginning. And this is the latest draft. And so this draft is focusing on the stateful NAT XY gateway performance measurement. So if you have any other idea should be added to this draft to make more reasonable measurement methodology for stateful NAT gateways, then we let us know on this room or on the mailing list. Okay, and we think this can be a potential working group draft. Thank you very much.
Thank you, Keiichi, and nice job keeping it within time. Quickly, let me ask if there's any questions, and if anyone's read the draft recently, to sort of go to the mic and comment. And we've had pretty good commentary on this last year in particular. Through the May-July timeframe, I believe, and so it's just it's really just a matter of you guys feeling comfortable, and we'll try to start a working group adoption after we get the Yang model sorted out, I think. So any thoughts on that from the working group? Okay. Well, kind of a quiet crowd here today, but that's all right. All right. So we'll proceed with an adoption call and see how that goes, and hopefully some of the folks who commented on the list will react to that, and then we'll have another draft to work on here in the group. But Keiichi, you and Gabor have kept up very well with your experiments, and that's great stuff. So thanks for sharing the results again today.
Okay, all right. Thank you very much.
All right, so next up we have the considerations for benchmarking network performance in containerized infrastructures. And I'm going to bring that slide up. All right. And Minnook Tran, are you with us there, Tran?
Yes, I'm here. Can you hear me?
Yes, yes, I can hear you just fine. Welcome to the group. I think this is your first time presenting as well, right?
May I start my presentation?
Yes, yes, go right ahead.
So hello everyone. So this is my first time joining an IETF presentation. So for this time, I want to give a presentation about the update of our draft, the consideration for benchmarking network performance in containerized infrastructure. Next slide, please. So first is a brief overview about our draft. So our draft is there to distinguish the benchmarking of containerized infrastructures from previous benchmarking methodology for VM-based AMP infrastructures. So actually, there are two kinds of things that we want to investigate inside our draft. The first is different network models that support packet acceleration technologies based on the vSwitch, and the second thing is a different deployment configuration that can make an impact on the container network. They are the resource isolation, loopage, or service function chaining. Next slide, please. So our latest presentation at the IETF event is, if I'm not wrong, is IETF 106. So at that moment, our draft is version 3, and from that time until now, we have moved to version 8. So this slide gives a summary of the update that we have made to our draft. So the first thing is the old section 3.1, that is a comparison with the VM-based infrastructures, and section 4, that is a benchmarking scenario for the containerized infrastructure. We have moved on and group it into the new section 3, that is a containerized infrastructure overview. Then we moved the subsection 3.2, and we moved it to the new section 4 in networking model in containerized infrastructure. So inside this section, we classify the networking models based on the vSwitch location. And the third update is we make the section 3.3 in version 3 that is resource consideration to the new section 5. And we rename it the performance impact to show different kind of resource configuration or deployment configuration that can make an impact on the performance of the container network. And finally, we add a new appendix section that shows our benchmarking experience to multiple hackathons that we have participated so far. Next slide, please. So this is the detail of the update. So the first update is the new section 3, the containerized infrastructure overview. So the first thing inside this section is a comparison with the VM-based infrastructure, which is the old 3.1. Then we classify different containerized deployment methods. So in the figure here, you can see there are 4 different containerized deployment methods. That is the CVNF on bare metal, or the VNF on the port on the bare metal, CVNF on VM, and the port on VM. And based on that classification, we make up 4 benchmarking scenarios for the containerized infrastructures. That is all section 4 in the draft version 3. So we rearrange and we rearrange all the section into the new one here, so to make our draft become more coherent for this section number 3. Next slide, please. So the second update is a networking model in container infrastructure. So the previous one is a container networking classification. So in our previous drafts, that include 3 kind of model: the kernel space, the user space, the SIOV. And to this draft, we have updated 2 new categories. That is the eBPF acceleration model, with notable use in Cilium and Calico CNI plugin, and the model combination. And this one is normally used in service function chaining case, where user space vSwitch is used for east-west traffic and SIOV used for north-south traffic. Next slide, please.
Okay. Well, I think you've got a question there, Bill. Did you want to ask a question on this particular slide?
Yeah, specifically on the combination model, did you consider using VETHs directly between the two containers for east-west traffic and eliminating the V switch altogether?
Can you repeat the question? I'm not hear it clearly.
Yes. Let me try speaking more clearly. In the model combination on the lower right picture, did you consider using a VETH pair between the two top boxes directly for east-west traffic, as opposed to going through the V switch between?
Yes, we use the VETH pair for the user space district.
Yes, I imagine you could eliminate the V switch altogether and perhaps get better performance by connecting the top two boxes with a VETH directly between them, rather than going through the V switch.
So you mean we use the SROV for the east-west traffic as well?
I'll send an email to you.
Thank you.
Yeah, in the physical world, it would be like connecting a crossover cable between the two Ethernet ports instead of going back to the V switch. Okay.
So the third update is the performance impact. So in the old section 3.3, we consider the hull plate, NUMA, and CPU isolation. And in this draft, we're adding two new impacts. The first one is service function chaining. And because we see that in every environment, physical network port is commonly connected to multiple VNF rather than a single VNF. And we consider two aspects in the service function chaining scenario, that is a number of VNF inside chains and different network access technologies that can be used to provide network service between the VNF. And the second impact is internode networking. So as we observe in the new ITSI documents, there are different internal networking technologies, and it may can make an impact on the container network performance, like tunnel employ VXLAN, BGP, or layer 2 underlay. So we added on to the additional consideration because we haven't make a test on it yet, and we plan to do it in our next IETF hackathon. Next slide, please.
And Tran, we got about a little less than 7 minutes left, so cover things, cover the most important things in the most amount of detail, please. Thank you.
Yeah. So the update number 4 is update session. We include our hackathon results. Next slide, please.
Okay.
So this is some of our update from the latest hackathon. So we make the benchmarking on the service function chaining scenario. We measure throughput when using SROV compared with the BPP, and we consider two scenarios, that is service chain in single node and service chain in multi-node. We also benchmark the impact of the number of VNF by increasing the number of ports inside a node from 2 to 4 to 6. Next slide, please. So this is our test bed. So we use two worker nodes, and the black line is used for the single node case and red line is for the multi-node case. Next slide, please. So this is the result we obtained from the hackathon 113. So the first is a comparison between the SROV VP and only VPP. We can see that the SROV performs significantly better than VPP, which is shown on the gray column. And the impact of the number of VNF inside chain is shown in the increasing number of the port from 2 to 4 to 6. And we also that it's only reduced throughput in a small package size, 64 and 128. For larger package size from 256, it does not make any kind of impact. Next slide, please. So this slide shows the multi-node scenario results. So we observed that the throughput in the multi-node scenario is slightly smaller than the single node with smaller packet size, less than 512, due to the increasing number of ports. And for the larger packet size from larger than 1,000, there will be no significant impact on the throughput. Next slide, please. So this is the next step of our draft. So first, we try to keep update the draft on the latest technologies. And in the hackathon, we test the internal networking technique that we add on the draft. We also want to test the eBPF acceleration model with and without the NIC uploading. And we use the result to prove our draft scenario and features. This is my last slide of my presentation.
Very good. Okay, thanks very much, Trent. Any questions? I know you went through the test conditions fairly quickly there, and it's good to see the directions that you're going, and that you're basically following all the draft scenarios with tests that you've conducted in the open where people can look over your shoulder. That's great. Any comments on the draft so far? All right. Well, Bill's going to get in touch with you by email about the V Ethernet pairing option, and that might be a way to improve performance as well by avoiding the V switch or the VPP. So I think that's something else you could try.
Yes.
And I mean, one thing we usually ask is how many people have read the draft. If you've read the draft and sort of want to support this work, just sort of raise your hand and get in the queue for a moment, and we'll be able to see that you're actively doing that. Oh, okay, good. Vratko's read it. Thank you, Vratko. Yeah, this is pretty close to the work that you guys have been doing in FDIO for a long time. So I would think that this would be a good place for cross-pollination of your experiences. So thanks for that. Okay. Well, if there isn't anything else, I think we'll move on with one last thanks to you, Tron, for presenting today. Good job. All right, Giuseppe, I'm going to bring your first deck of slides to the...
Hello, can you hear me, Al?
Yes, yeah, I can hear you very well.
Okay, good.
Welcome to the benchmarking working group here. And I know you well from IPPM work, but this crowd may not have that crossover. So welcome, and welcome to anyone in your author team that's present as well. So it looks like we can go with 14 minutes again. So that's what we're going to do, and go right ahead whenever you're ready.
Okay, yeah, this is a new work about benchmarking methodology for MPLS segment routing. This is already 0.1 version, since we got some input from Luis from Telefonica, and we included also him as co-author. So next slide.
Okay.
Yeah, just a background and the motivation for this work. There is an RFC 5695 that describes the methodology for benchmarking MPLS forwarding device, while segment routing that defined in RFC 8402 is applied to MPLS data plane, and we found interesting to understand how to benchmark DSR MPLS behavior. And we didn't find a standard method defined to compare and contrast the fundamental SR MPLS forwarding capabilities. So this new draft aims to complement RFC 5695 by defining the methodology for SR MPLS. And of course, it builds upon RFC 2544, 5695, and the base as segment routing RFC. Next slide. Yeah, just a recap about the SR MPLS operation. So segment routing is applied to MPLS architecture with just a minimum change to forwarding plane. In particular, a segment is encoded as an MPLS label, and an SR policy is instantiated as a stack of labels. So there are three fundamental operations for SR MPLS, that is push, next, and continue operations. So push consists of the insertion of a segment at the top of the segment list. Next consists of the inspection of the next segment, and the active segment is completed and the next segment is active. And continue happens when the active segment is not completed, so it remains active. Next slide. Yeah, now we can see what this draft can keep similar or equal to RFC 5695. In particular, the device under test is connected to test ports and test tool according to RFC 2544, so not big change from this point of view. Also, the recommended topology for SR MPLS forwarding benchmarking can be the same as MPLS, so as described in RFC 5695, for both single port and multi-port scenarios. And also the frame characteristics can be basically the same. We can see some changes in the next slide, but the frame characteristics can be the same. So next. Yeah, in this draft, we want to summarize just the initial proposed change from RFC 5695. So first of all, we need to recommend that the device under test support an SR extension for dynamic IGP, such as ISIS, SPF, or BGP. In addition, there is a big limitation in RFC 5695 because it requires exactly a single entry in the MPLS label stack. But with SR MPLS, the number of entries in the label stack should be generalized in order to benchmark an SR policy. So this can be one change that we need to do because the number of labels must be chosen, also taking into account the maximum frame payload size that is also given by the RFC 5695. And in addition, there are new parameters that need to be specified and also need to be reported. Which forwarding operation, so push, next, or continue, the number of segments that are considered, so because this may affect the benchmark performance. Also, whether global seed or local seed are used, so which forwarding behavior is used, and also whether we are talking about, let's say, benchmarking an SR policy head-end or endpoint behavior. Next. Yeah, in comparison with the benchmarking tests that are defined in the RFC 5695, there are a lot of similarity, of course, because the push operation that I have described correspond to the label push function in RFC 5695. And the same happens for the next operations that correspond to the label pop function and the continue operation that correspond to the label swap function. So the only change is related to the number of to the number of labels and to the structure of the SR policy. And also the reporting format is going to change. So next slide. Yeah, what are the next steps? So we welcome feedback from the community because there are some pending points that also were raised during the discussion with Luis. For now, the current approach of the draft is to extend the RFC 5695. The alternative can be to rewrite some text from that RFC and to create one more convenient document for the reader. Otherwise, we can just refer to the text of that RFC. In addition, RFC 5695, as I said, includes only one label in the stack, so it may be needed to test more labels to support SR policy. Also, in this case, we need to discuss how many labels can be a reasonable number. So but in any case, the number of labels must be reported. In addition, a good point that was raised by Luis was the opportunity to consider additional background traffic in place. So he suggests to add also these scenarios. And another point is about the traffic engineering test, because we noticed that usually in benchmarking working group, traffic engineering was in a separate document. For example, we see RFC 6894 that is separate from 5694.5. So also in this case, your input will be welcome to see if we have to include also the traffic engineering test in this document or we can keep in a separate one. Of course, we also are open to new co-authors, new contributors, and welcome comments. So thank you.
That's great. Thanks, Giuseppe. Any questions and comments at this point? Okay. Well, let me get things started because I've read the draft. One of the things I saw is that when it comes to the throughput and latency and other measurements that that are were originally defined in RFC 2544, there's been some sort of piecewise updates to the way these measurements are made. For example, when one of our collaborators here was doing the initial work on state state transition, and I think it's RFC 8219, but memory escapes me at the moment. In any case, we'll get that right number for you. But the like I said, we've kind of been updating RFC 2544 on a sort of a section by section basis. And right now, the test equipment that generally measures RFC 2544 systems does a lot more with latency than the original 2544 anticipated that equipment could do. So, this idea of measuring, if you went back and read it, Giuseppe, you saw that it's a measurement of a single packet. And, we just can't stand that anymore. So, at least the test equipment that's out there today will do like a minimum latency, a maximum, and an average. And we have some aspirational stuff in this. I think the RFC that I'm talking about, and it would be better to reference like the latest latency measurement material along the way here. So I think a few comments like that will help. so that we're not kind of blindly referring back to stuff from 20 years ago. We have made some changes, and it would be good to incorporate those references in your new draft.
Sure. Thank you for the comment. I was not aware of this document, so I will have a look, and I will also integrate into our draft, also in relation, as you said, because we have to consider the minimum, maximum, average, so more statistics, data, and yeah, I will have a look and revise the draft, of course.
And one other thing I would like you to consider is if you're implementing any of these devices under test in a virtualized world, virtualized networking and instantiation, then you probably want to take a look at a document from one of our sort of collaborating organizations. That's the ETSI Network Function Virtualization Test Working Group. They have a document which has been updated fairly frequently on benchmarking in the in the virtualized test environment. So and there's some good suggestions there about additional measurements that can be made, and additional stuff on latency, back-to-back testing. In fact, yeah, we have an update on the RFC 2544 back-to-back testing procedure, which I think is RFC 9002. And with that update, it's a much more viable and useful benchmark to measure. So you might consider including that as well. I don't think I saw that in your list of benchmarks. It's the back-to-back frame benchmark.
Yes. I will look at also at this document. I saw that there was this update of RFC 2544, but yeah, I didn't have time to look at it, but I will do. Yeah, and in case, of course, the use of maybe an additional scenario of the virtual machine is also interesting to be evaluated, of course.
Yeah, that's kind of a window for you to try out some of these tests, and like you just saw with in Tran's presentation, and earlier today with Vratko's presentation. This is a testing working group, and everybody resonates when they see testing results. So if you really want to grab everybody's interest, put some graphs or some tables up on your charts, and the blood will really start flowing here. Okay.
Yeah, sure. This is just an initial proposal, also to see the interest of. Of course, we aim to improve and also to receive your feedback, because we find that the possibility to benchmark segment routing can be a good tool for operator or for people that would like to deploy this technology. So that's why I think it's important. But we also want your feedback to, considering your experience, to integrate and to make the document more useful for the community.
Yeah, sure. And my thought at the moment is to keep TE out of scope for now. Let's see what progress you can make with the suggestions I gave you today, and actually running some tests. I think that would be good as well. So
yeah,
that'd be good. All right, and then you're up for the next one here. We have a comment from Edouard V. Please go ahead.
Do you hear me?
Yes, we hear you now.
Okay, fine. I have a question to the working group. about background traffic. It may be very different. Do you know, anybody of you, do you know any RFC or any maybe even draft, okay, draft is enough, where background has been specified, background traffic, because it's difficult to guess what it could be. It may be very different.
Yeah, yeah. It's not typical that the benchmarking methodology working group talks about background traffic. Usually, we're in an isolated lab setup. All the traffic is synthesized traffic, and it comes from the test equipment and goes back to the test equipment, and so we're not really sort of setting a like a real world, an attempt to simulate real world traffic in any way. It's all test traffic. Does that kind of answer your question?
Okay. Answer no is the answer too, because yeah, if nobody did it before, then it's answer. Yeah.
By the way, there is a draft that's sort of attempting to do that in the responsiveness measurement area, but that's in the IP performance metrics working group. And I think that they're still trying to specify what it means to have like a working level of load, and they're currently doing that on the basis of good put and an iterative algorithm to do that. But like I said, we're not touching anything like that. So, but if you go to the IPPM working group's agenda from Monday, first session, you should be able to find that draft on responsiveness fairly easily.
Thanks.
Yeah, sure thing.
So for the moment, your suggestion is to keep the background traffic out of scope. So, and let's see later.
Yeah, it's. I mean, unless I understand it better, I think it's more appropriate just to go with, the way we've done things in the past here. It seems like all your references go that way, so that's what I would suggest. So let's look at the V6 segment routing.
Yeah. Okay. Yeah, you can go on next slide. Maybe let's say the background is the same, but
right. So I'm giving you less time.
yeah. Next. Yeah, the background is the same. So, but it applies to another RFC, that is the RFC 5180. That define the benchmark methodology for IPv6 devices. A segment routing can be applied to IPv6 data plane. So this new draft aims to complement RFC 5180 by defining the methodology for benchmarking SRv6. So next. Let's say in comparison with the MPLS RFC, now with SRv6 there are more changes to the IPv6 architecture. Also, if you go in 6 months, there was a new draft that analyzed all the change of the SRv6 to IPv6 architecture, because with SRv6 a new type of routing header has been defined. The segment is encoded as an IPv6 address, and an SR policy is an ordered list of SRv6 seeds in the SRH. There are 3 categories of nodes that in this case are similar to the Sr Mpls behavior. So the source node, that is the head-end node that steers the packet into an NSR policy, the transit node that forwards packet as a normal IPv6 packet, and the SR endpoint node that receive packet whose destination address is configured locally as a segment, and so it replaces the IPv6 destination address with the new active segment. So this is just to recap the SRv6 operation. So next. And in addition to the basic SRv6 packet processing, there is also the SRv6 network programming model that has been defined in the RFC 8986 that describe a new set of function, because the 128 bit of the seed can be split into 3 different fields: locator, function, and arguments, and the list of behaviors is specified as a subset of function that can be also tested to benchmark the SRv6 network programming capability. So this is an additional, let's say, things that we have to consider with SRv6 that we don't have with Sr Mpls. Next slide. Yeah, regarding the test methodology, also in this case, there are some similarity with RFC 5180 regarding, for example, the device under test connected to the test tool. Also, regarding the test topology, it may be considered the same as in the previous document, and the frame characteristics. Also considering that in RFC 5180 there are several considerations on the IPv6 addressing space that can be considered, so we can keep the same consideration also here. Next slide. Yeah, as I mentioned, for SRv6 there are more changes to do. First of all, the first change is similar, so we need to support extension for IGP protocols that are also defined in several documents. But the first big limitation in the RFC 5180 is that it recommends a limited extension header chain for testing. I have reported that it includes a routing header of maximum 32 bytes, destination option header, fragment header, and this is not enough considering the typical scenario of SRv6 deployment, because, for example, the length of SRH is n per 16 plus 8 bytes, where n is number of segments. And if we consider a number of segments, of course, that is greater than 1, the limitation of the limited extension header chain of RFC 5180 is not enough for SRv6. So maybe we need to do this change, and in addition we have to add more parameters: the type of nodes, the number of segments in the SRH, the characteristic of extension header chain that maybe need to be redefined, and also the behavior in terms of network programming model, as I mentioned before. Next. Yeah, maybe we can skip this slide. So just for sake of time, this slide just describe the basic tests that are already defined in IPv6 forwarding case, but need to be added in this new document, because we have to distinguish between the processing of SR source node, SR endpoint node, and SR transit node. So new tests need to be added here, because this, let's say, classification was not, of course, included in RFC 5180. Next slide. I think it's the last one. So we are on time. Yeah, also in this case, there are some pending points and feedback is welcome. The first point is similar to Sr Mpls. The second point is what are the functions that we must test. So we need to consider all the behavior that are included in RFC 8986 or just a subset of that. Additional question, there is an activity on compressed seed. So should we cover also compressed seed test? But we should consider that the reference document is still in progress, so we may add this in a future version. Then, okay, the question on background traffic that you already answered. And the question on traffic engineering task that you already answered. So basically, yeah, the second and third questions are specific for SRv6 case. So yeah, thank you and welcome comments. Yeah, input.
Okay, Edward, you're in the queue. Please go ahead.
A little bit comment more about function, because in the Service 6 function is not just like VPN services like layer 3 VPN. For some transit nodes, there are functions like AND and X and T. It's for transit nodes. Therefore, we could not include function at all. We could include in the test a function which is related only for transit nodes, effectively for transport, effectively. And of course, we could include all functions, but all functions is a huge list, which I doubt should be included here, because all functions is already VPN, and VPN is typically different document. Probably VPN should not be included. But about transit functions and X is for traffic engineering, especially for index, because it's traffic engineering, and maybe traffic engineering is different document. Maybe index should not be included. I don't know. Therefore, it's a question. Sorry for interruption.
That's good. Thank you, Edward. Yeah.
Yeah. So, any response to that, Giuseppe?
No, this is something that I also put in the slide. So what are the functions? Should we consider only the basic and X?
Oh, yeah.
Or does define the complete list of RFC 8986? So yeah, this is something we can do a proposal. What we also need feedback from the community, from the operators. That is one of the main points that we want to address, for example, by the next meeting, to get more feedback from operators. Yeah.
Yeah. So I think you're really going to have to beat the drum about this to get the feedback you want. The quick feedback I can give you, because we've reached the end of our session, is we've got this reference through 5180 to 2544, and there's even less about the actual procedures of throughput and latency and other forms of benchmarking in the actual test procedures in 5180. I think it was pretty, most of the sections on throughput, latency, and so forth are pretty transparent and just pointed to 2544. So like I said, a lot of that stuff has been updated, and we've got to collect the right things for you to be referencing, separate sections of more up-to-date documents, and that will be a good thing.
Yeah, this will be great if you can point out to these more updated stuff, more updated RFC. Yeah, we can include and read, of course.
Yeah, good. Okay. And if you just take a look through our literature, there's a good chance that you'll stumble over some of these things as well yourself. So that's always a good starting place, right?
Yeah. Of course, I will do. Maybe I will ask you to confirm if that's the right document, of course. But
I have to say, I don't think we've ever updated anything more than once from RFC 2544. So if you find something that updates 2544, it's probably a good thing.
Okay.
All right. Okay. Well, thanks for those two good presentations and good proposals. And I think any other business today? No? Sarah, any final thoughts?
Lots of things to take a look at, lots of things to read. So please, everybody, take a look at the drafts. Feedback's always welcome. Al often teaches us when I first joined the group, hey, if you want feedback on your draft, it's really easy to do when you're reading others and sharing feedback on there. So please take a look, share your feedback on the list. It's always appreciated. Thank you.
Yeah, great point, Sarah. That's one way to join the group is provide feedback on the other work that's going on. Excellent. So I highly encourage that to folks who are looking for their work to be adopted. Okay. So thanks, everybody. Thanks, Warren, for standing in as our delegate. Good to see everybody. Good to see you, Bill. And I know Kariti left already, but it's at least good to see you guys on video. A little better than it's a little better than gather. And we'll talk to you again on the list, and hope to see you in the city of brotherly love, Philadelphia. Bye for
Thanks,
now.
Bill.
Bye. Thank you. Pillow, don't abandon me.